Section 2.1, what is a function? Functions are all around us, even in the real world. Your height is a function of your age. Your cell phone bill might be a function of how many text messages you sent and received, or how many minutes you used on your phone. And your class grade in this class even can be a function of the amount of work that you put in or your understanding of mathematics. So the actual definition of a function is a rule that assigns to each element x in set A exactly one element called f of x in set B. So what that means is we have this set of numbers that we'll call set A with some elements in it. And we have this other set that we'll call B with some other elements. What the function does is it takes one element, x, and assigns it to an element in B. So once you have this assigning, that's called a function. If this element is called x, over here in B, this would be f of x. If this was a, the value that it was assigned to would be called f of a. All of these elements over here in the set A, these are called the domain. And then all of this in this case set B, this is the range. One helpful way to think about a function is like a machine. You can input a number, and then you don't quite know what it does, but it spits out a different output. So in this case, we input 1, it spits out 2. When we input 2, it does its thing, spits out 4. When we input 3, it spits out 8. And when we input 4, it spits out 16. In this example, it didn't specifically tell us what the rule is, but we do see here that the inputs are 1, 2, 3, 4, and the outputs are 2, 4, 8, and 16. So the inputs are your domain, your outputs are the range. Example 1, the squaring function. The squaring function assigns to each real number x its square, x squared. It is defined by f of x equals x squared. Evaluate f of 3. So that just means to plug in 3. So we have f of 3 equals 3 squared. We square it, which is 9. So f of 3 equals 9. F of negative 2 means plug in negative 2, so we have negative 2 squared. Negative 2 times negative 2 is 4, so f of negative 2 equals 4. And finally, f of negative 5, or square root of 5, means we're plugging in the square root of 5. So it's the square root of 5 squared, which just equals 5. So f of the square root of 5 equals 5. For part B, find the domain and range. It's a little bit more difficult. You really have to think about the function. You have to figure out what elements can you square, since the function is x squared. It doesn't matter what you plug in. You can plug in a whole number, integer, rational, fractions are okay, decimals are okay. Even irrational numbers like square roots and things like that are okay. So the domain is all real numbers. Everything is okay. Domain, you can say all real numbers. There's actually an abbreviation, a little symbol for all real numbers, which is just, it's an R, but with two stems, we'll call it. The range is a little bit more difficult. You have to think about, once you plug in every real number, what sorts of outputs do you get? What might the machine spit out as an answer? So, for the most part, with squaring function, usually it's just going to be a larger number. 0 squared is 0, so 0 is an acceptable output. You can really get just about anything. There's the only thing that you won't get when you square is you can never get a negative number, because negative times a negative is positive, and positive times positive is positive. So there's no negatives. So you could write that as an interval for the range. You could say 0 we said was okay, so you can include 0 up to infinity. Or you could write it as an inequality. You could say it's a set of all x's such that x is greater than or equal to 0. Or you could do it as an interval like this. Actually, since this is the range, we shouldn't say x, we should say set of all y's such that y is greater than or equal to 0, because it's the range, it's the output, so we'll use y as the variable. This next example is about a piecewise defined function. A piecewise function is split into pieces, and they tell you where the split happens. So in this case, if x is less than or equal to 1, we use the top part of the function, 1 minus x. And if x is more than 1, then you plug it in to x squared. So it's a different rule that just depends on what value of x you're plugging in. So we're going to evaluate at -2, 1, 2, and 3. So let's start with -2. F of -2. So since -2 is less than or equal to 1, we're going to use the top function. 1 minus x, so that's 1 minus -2, which is 1 plus 2, so 3. So f of -2 is 3. 1, when you plug in 1, that's less than or equal to 1, so we're still using the top function. So that'd be 1 minus 1 is 0. Now we're going to plug in 2, f of 2. 2 is greater than 1, so we're going to use the bottom function, bottom part of the piecewise function, x squared. So 2 squared is 4, so f of 2 is 4. And finally we're plugging in 3. 3 is also greater than 1, so we're plugging into the bottom part of the piecewise function, 3 squared, which is 9. So f of 3 equals 9. When you're evaluating a function, it's not always numbers that you're plugging in. Sometimes it's letters or even expressions. So if it just plugs in another letter, like f of a, all you do is you substitute all of the variables, x, in this case, since the example is f of x equals 2x squared plus 3x minus 1, we're going to substitute all the x's with what's in the parentheses, in this case a. So it'll be 2a squared plus 3a minus 1. Similarly, if we're plugging in negative a, evaluating for negative a, you just plug in negative a wherever there was an x. Negative a squared plus 3 times negative a minus 1. And then do some simplifying. Negative a squared is a squared, so 2a squared. 3 times negative a is negative 3a minus 1. Or, if you're plugging in a plus h, it's the same thing. Wherever there's an x, you write a plus h. So f of a plus h equals 2 times a plus h squared plus 3 times, instead of x, we'll write a plus h minus 1. Then again do some simplifying. So a plus h squared, that's going to be a squared plus 2ah plus h squared plus 3a plus h minus 1. Some further simplifying with distributing. So 2a squared plus 2 times 2 is 4ah. 2 times h squared, 2h squared. Distribute the 3 here. 3a plus 3h minus 1. Combine like terms if there are any. A squared, there's no other a squared, so 2a squared. Ah, there's no other. There's no like terms here at all, so we're done. And then finally, we already did f of a plus h and f of a. So let's just go ahead and combine these, put them together. So we would have this whole part written here in green. 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1 minus part from part A here, 2a squared plus 3a minus 1. You need to distribute that negative, all of that over h. So we do want to simplify this top. So distribute your negative. Negative 2a squared minus 3a plus 1. 2a squared minus 2a squared, so those are going to cancel out. Minus 3a and a positive 3a, those are going to cancel out. We have a plus 1 and a minus 1, so those will cancel out. So we're left with 4ah plus 2h squared plus 3h over h. We can cancel an h from everything, so that just leaves us with 4a plus 2h plus 3. These are more complicated, but you'll see things like this in calculus.